my assignment is to cover some things that I've been interested in, and then to segue into the panel discussion that's to follow. Hopefully, I'll do a proper job of that. You know, for thousands of generations, human beings have looked at the night sky in wonder, and also in conjecture. It took tens of thousands of generations of human beings to get up to where we are now, and at the level of understanding that we have of the universe, and even of our own world. The conjecture that these phenomena of the sky at times went against, we'll say, conventional wisdom and taboos. Think here relatively recently, think Galileo and the Inquisition, kind of get an idea of the taboos. But yet by the time we get to the ancient Greeks, we have a society within which has individuals who are actually wondering about whether we are alone. And that if there are beings, intelligent beings, somewhere else in our universe. Now, a great leap forward took place with the Copernican or scientific revolution back in the 17th century that helps us really get a focus on an understanding of the universe and humanity's place within it. Of course, it's named after Nicholas Copernicus, the man who took us from the Ptolemaic, Earth-centered universe to a heliocentric view of our solar system. In those days, the solar system was the universe. It had a number of key individuals. Nicholas Copernicus was one. Tycho Brahe was another. Mathematics of planetary motion and other important observations. John Kepler derived the basic laws of planetary motion, indicating that orbits were ellipses. Galileo Galilei, who with his telescopic observations in astronomy supported that heliocentric view, which he also supported when he published his dialogue concerning the two chief world systems, which then led to his trial and house arrest by the Inquisition, again going against a taboo, in this case a religious taboo. Giordano Bruno, who argued for an infinite universe. They are supported by Descartes. And the last persona that I've added here is Isaac Newton, who completed the scientific revolution with the publishing of the Philosophiae Naturalis Principia Mathematica. And among other things indicated that planets were kept in orbits by gravity. Now that scientific revolution unifies thinking about the universe. There's a more coherent scientific and philosophical understanding of the universe and man's place within it. And it reintroduces a question, now with increased fervor, that was first posed by those ancient Greeks, and that was, are we alone? Early discourse in this question that blossomed in the 17th century was through this book, The Plurality of Worlds, which was written by Bernard Le Bouvier de Fontenelle, and that's as good as the French gets. In this book, he explains the heliocentric model and also further discusses the possibility of extraterrestrial life. A unique thing about this book is that this is written in common terminology. It's common language. It's actually kind of a novella where the philosopher is taking a walk in a garden with some young woman, and this is the topic that they are the topics that they're dealing with. Now, at this time, we have minimal instrumentation. for observationally getting an answer to this question, are we alone? And so a little different tack was taken initially. And that was, the first attempts were to call attention to our presence and then see if there was a response from off-world, principally places that were close to us, like the Moon, Mars, and Venus. Actually, they refer to the inhabitants of the Moon and Mars. One of my favorite books, or I should say favorite movies, talked about what involved a trip to the Moon in 1899, and the Selenites, which kind of looked like grasshoppers, I'm not sure, that inhabited the Moon. Unfortunately, when the Apollo program finally got there, they found no signs of them whatsoever. I picked out a couple of these early proposals at communication with other planets. Start with Carl Friedrich Gauss, who put forward this notion of constructing the outline of the Pythagoras, and that's this collection of geometric shapes out in the tundra of Russia, or even cutting pathways through the forest and revealing these shapes. Von Littrow talked about, this is kind of a crazy thing, digging circular, well, I'm not saying anything else isn't crazy either, but yes, right. Digging circular canals up to 30 kilometers in diameter in the Sahara, filling them with water, I'm not sure where that's coming from, and then floating fuel oil, kerosene on top, and igniting it at night, and then sitting back and waiting to see if there's a response from off-world. Charles Cross put forward the notion of celestial telegraphy, using light beams, using one or more powerful electric lights focused on parabolic mirrors, and use them to exchange some kind of repetitive signals. We work out some kind of code over time with the inhabitants of Mars and Venus. And of course, something that was pointed out earlier by David, the famous Nikola Tesla, also thought it might be possible to send signals to Mars by means of extremely powerful electrical discharges. He postulated there was a medium between the planets that would carry this electrical charge. Well, then the excitement in the notion of extraterrestrial civilizations really gets a kick up when we get to the end of the 19th century. Start with Schiaparelli. The man spent 20 years studying Mars. He constructed these interesting maps. Of course, and he noted, he was the first to notice these linear features. And he thought that they were natural geological features. And he called them channels. And of course, he called them channels in Italian, canali. And whenever it got translated into English, it became canals. And of course, this excited a lot of people, but none more so than Percival Lowell, who, a very charismatic, wealthy, imaginative person, who became enchanted with Mars at this day and time, built that wonderful observatory near Flagstaff, and went on to detect on his own through that telescope about 500 canals on Mars, as well as a couple of hundred dark circles that he called oases. And then he went on to postulate then that there was an advanced civilization there. The canals were for moving water, especially from the polar regions down into the really dry mid-latitude so they could raise crops, and etc. He wrote a number of books that were fairly popular today. Mars, Mars and its canals, Mars as an abode for life. Of course, this also is something that these conclusions were kind of problematic because they were very difficult, like impossible to substantiate. And this introduced something into the field that has bedeviled the whole field of thinking about extraterrestrial life ever since, and that's the giggle factor. Politicians love to latch onto this. I'll talk a little bit here later on about the demise of a NASA program because of the giggle factor, or we'll say perceived giggle factor. Okay, in 1959, we have a game-changing seminal paper. This is the first paper to be published on the SETI discipline. And I'm going to say it's Coccione, close. Okay, Cocconi and Philip Morrison, I know that one. Both who were at Cornell University wrote this paper, Searching for Interstellar Communications. And this paper is really still quite valid in that it lays out the ground rules of basically how to conduct a search in the microwave region for the presence of extraterrestrial technical civilizations. It's still a blueprint for modern SETI, with the exception of the fact, of course, modern SETI has also transitioned into optical SETI, as we're looking for the laser beams and other things that's going back and forth between star systems. They selected this unique frequency, the water hole there down at the neutral hydrogen, 21 centimeters, rounded off 1420 megahertz. They expected the signal to be pulse modulated, to be long duration, maybe even years, and to be repetitive. That is, if someone is trying to contact the rest of the universe. Really, it's more reasonable to think that signals that we might pick up would be incidental signals as a result of just the ongoing everyday of civilization. Years ago, when I was in the military, we worked with, I worked in the intelligence field. One of the things we would do is we had very powerful radar units. We projected 10 million watts. And in order to calibrate the things, one of the things we used to do was pan it across the surface of the moon and map the profiles of the craters. Okay, well, you can beam that on out into space too, as you're trying to find the moon on your first or second attempt. And those things are probably more likely. That could be, someone mentioned earlier, I think it was Rick Matloff, and that was the wow signals. Things that just kind of pop up, they're non-repetitive, and you never find them again. Let's see. And then they also picked out a target list. 15 light years. There are 7 stars with luminosity and lifetime similar to our own. And 4 of them lie in the direction of low background. They're in the southern declination. Well, at the same time as this paper came out, Frank Drake, a newly minted PhD out of Harvard, got a job at the National Radio Astronomy Observatory in Green Bank, West Virginia. And he was already planning a SETI search at 2 of the 4 nearby stars that the Morrison and Cocconi paper had mentioned. So for a few weeks in the spring of 1960, Drake's Project Ozma was undertaken using Green Bank's brand spanking new Howard Tuttle 85-foot, 23-meter dish. It looked at a narrow band of frequencies surrounding hydrogen's emission line, and this is the birth of observational SETI. He did succeed in picking up a transient signal two nights in a row, emanating from an unknown aircraft, cruising at an unheard of altitude, 80,000 feet. What he had done was he had discovered secret flights, testing flights of the U-2. And he did choose not to publish what he found because he rather suspected that it was military in nature and they'd probably get a knock at his door if he tried to publish it. Well, a year after Project Ozma, Drake convened a meeting of about a dozen individuals at Green Bank. And this group eventually would take on this term, the Order of the Dolphin, because one of the attendees actually worked in research in the area of dolphins. And it was for a week-long discussion centering on 7 topics. that involve various astrophysical, biological, technological, and societal aspects of the potential emergence of interstellar communication with other worlds. And he strung those topics together in a multiplicative model, which became known as the Drake equation. Basically, what this thing is not something that you're going to sit down and solve, but it's something to guide your thinking process. Though we might actually arrive at a point where we can solve it, because some of these factors are actually being filled in, like the R star, the average rate of star formation. I guess it's about 1 a year now in our galaxy. The fraction of those stars that have planets. And we get a little later on here in planetary searches, Kepler, HARPS, and others, you find out that an awful lot of stars have planets. The average number of planets that can support life, and so on. Those that go on to develop intelligence, those that develop interstellar communication, and how long those intelligences will release those signals out into the cosmos. Another way of also looking at that right there is the length of your technological civilization. And of course, this was the infamous black box when this equation came out, because this is, we are so deep into the Cold War and the nuclear genie, and who's going to use it, and are we going to avoid it, that sort of thing. So that was a rather major question mark. But we've had a half century now of SETI science. NASA had a program from 71 to 93. At its peak, it ran $12.6 million a year. The program was ended just 1 year into a 10-year observational cycle that it had started. It's looking at these huge multi-channel spectrum analyzers, best antenna available. They're looking at the whole sky, and Congress saw it as something easy to chop. Of course, prior to this, I guess it was in the 80s, the SETI project at NASA received the infamous Golden Fleece Award from William Proxmire. And the following year, funding was zeroed out. Funding got restored by the personal intervention of Carl Sagan, who went to Proxmire and sat down, and you know how persuasive Carl Sagan could be. Man, he's an amazing individual. But he didn't sway him to his point of view. All they did was get him to commit to not oppose the bill, the funding bill. And then it was funded for a couple of more years, and then some other people from Congress decided it was time to cut it. Well, since then we've had the privatization of SETI. That's given rise to the SETI League and the SETI Institute. It's grown from the microwave region. We have optical SETI and so on. So, and a lot of resources. Recently, I guess I read that there's a chance they're going to lose the antennas that belong to Berkeley, but they'll pick up time on other antennas somewhere else.
They did a fundraiser and they brought it back. They actually went down for a couple of months, and then they did a huge fundraiser and they're back up.
Sweet.
Jodie Foster, I believe.
Jodie Foster? Yeah. I should hope so. Okay, gonna transition here to filling in the blanks of the Drake equation. We're going to do this through observations, both ground-based and spaceborne, and modeling. It takes in various aspects of astronomy, astrophysics, biology, geology, every ology you can think of, I guess. And pictures then being built in which both galactic habitable zones and stellar habitable zones are being hypothesized. The galactic habitable zone, it's long been thought, it's basically been postulated to be a ring. It's about 6,000 light years in diameter. Sits outside of the central bulge. Why is that selected? It has to do with the combination of the metallicity of stars. You've got to have a certain metallicity if you're going to have planetary formation. Stellar density. One of the things that's precluded the thinking about going into the central bulge, into the inner part of the galaxy, is nasty events, especially supernova. For instance, a type 2 supernova, when it decides to light up, will sterilize at least biology like us in an area, in a zone up to 8 parsecs in diameter. So if you've got a high stellar density, we're kind of lucky. We're out here in kind of the suburbs, actually we're in the suburbs. We're out on the edge of the countryside here. And so the statistical chance of being subjected to this is really rather low. Our case is very low. A recent paper, though, by Galactic and co-workers suggested the zone should actually be spread into the central bulge as well. And I think it's the December issue of Astrobiology, but I won't swear to it. Also, they do some modeling, and they predicted 1.2% of all stars host a planet that's capable of sustaining complex life. Also, I think it's 0.03% of all planets of all stars have a planetary body in the Goldilocks zone that is not tidally locked. So it's freely rotating like our own planet. Stellar habitable zone, this is a real simplistic view of it. It would be a zone basically where that would allow for liquid water to exist. At the real simplistic level, it's simply a matter of how hot the star is and how far away from it you are. Of course, there's a lot more to it. Most of it has to do with planetary conditions, atmospheric, and so on. We're not going to talk about that. Actively searching for exoplanets. First exoplanet was discovered in 1991. It orbited this pulsar, B1257 plus 12. First planet around the main sequence star was 51 Pegasi b. It was discovered in 95. Currently, there are 2 wildly successful programs for finding planets around other stars. The first is HARPS, High Accuracy Radial Velocity Planet Searcher. This is a spectrograph that's fitted to a 3.6 meter telescope at the ESO's La Silla Observatory in Chile. It measures radial velocities to an accuracy of 1 meter per second. So as a star has a planet going around it, you get this wobble in the star, and you get this Doppler shifting, and that's what HARPS measures. Currently, they have a list of close to 600 planets, potential planets, with more than 150 confirmed. Second is NASA's Kepler mission, which is a big, it's a telescope in space. It's got 42 CCD elements on it. It's to determine the frequency of Earth size and larger planets in the habitable zones of sun-like stars, and determine their size and orbital period. Again, it's 42 CCDs. It stares constantly at a field with 156,000 stars in it. Right here we are out in the suburbs, and it looks into an area here about 3,000 light years. It's slightly above plane of the ecliptic to lower the background from stars that are in behind. It was mentioned earlier that this thing works by transient light curves. You get this little drop due to sunshade effect as the planet goes by. As of November 15th, had 1,235 candidates, 25 of them confirmed. And this is the pattern that the CCDs look at, and the various planetary candidates that they have found thus far. Okay, after 50 years of SETI searches, and in light of the evidence of the existence of hundreds of planets within 300 light years of us, and with this elucidation of stellar habitable zones and the galactic habitable zone, there's still no evidence that exists of the presence of other communicating civilizations in the galaxy. There are possible exceptions. My favorite's the WOW, one of the 30 or so WOW signals, the one from August of 1977. It's going to take me back to what we're going to use to segue into the next hour. And that is the Fermi paradox. Because this lack of finding signals plays right into the Fermi paradox. In the summer of 1954, scientists, these 4 guys right here, Fermi, Teller, Yorkin, and Konopitsky, are walking to Fuller Lodge at Los Alamos. They're going for lunch. And they're having a discussion about a cartoon that appeared in the New Yorker that was trying to explain two current things in the news. One was the sightings of UFOs, and the second thing was the disappearance of public trash cans off the streets of New York. And the editorial cartoonist came up with that. Fleeing the spaceships, and they're at their home planet there. They'd come to Earth. It was a raid. They came to steal New York City's trash cans. And during this conversation, Fermi says, well, where is everybody? Where is everybody? And that's the Fermi paradox. You know, it's a verbalization of the contradiction between the probability estimates of extraterrestrial civilizations and the lack for any evidence. And this is what we're faced with, the great silence. And the question is, why?
Thank you very much. Without asking him to solve the answer to the Fermi paradox, are there any questions about the rest of the talk?
Yeah.
Well, first of all, let me congratulate you, because your presentation was detailed and excellent in all regards. I work in the SETI business. I've been working for 20 years, so let me just add a few more points, please. First of all, for you American people, just last week in Paris, we had a workshop, more or less like this one, more towards SETI than this one. Unfortunately, it was not in English, it was in French. I don't like that because I believe that English should be the international language. Anyway, they pointed out a few more extrasolar planets that were discovered by the European mission Coral. Coral was not involved intentionally to find extrasolar planets, but some of them were discovered. Then let me point out that next week at NASA Ames, there will be the first Kepler science meeting. I'm going there. It's going to be a large conference. I don't know, there are 200 people more. So there are many more poster papers than people allowed to give talks, because there are so many. But that's really the first big gathering of scientists working in this field. And of course, we are going to try to find out statistics of extrasolar planets. So this field is growing up tremendously, to the satisfaction of every scientist involved. Thank you.
I was wondering if it might be more beneficial to science if we look for any type of life, even though it was simplistic, fundamental, like one cells or something, you know, like lower animal and lower forms of vegetation or things like, in other words, more elemental types of life might be more constructive to science in the short term. It maybe would help give us some insight into what we might do as far as searching for extraterrestrial intelligence.
I think you'll find that some motivation behind NASA's programs and the European Space Organization's programs. They can't go out, you know, like the planet searches. They're looking for worlds. Of course, they're looking for worlds in the Goldilocks zone, and eventually, hopefully, through spectrometric means, we'll be able to look at atmospheres and make some conclusions about whether or not there's life there. But yeah, I mean, the great silence, as far as at least electromagnetic spectrum communications, is such that this is.
The reason I asked that question is because we already know that life that we found, say at the deepest parts of the ocean on Earth, near some of the vents where there's hot water coming up and things like that, is radically different than anything anywhere else. And so,
there was a drilling program at the Pacific Northwest at PNNL 10, 15 years ago, 20 years ago, and they were actually finding bacteria 3 miles down in solid rock.
Stream of thoughts.
Yeah.
All right, well, very good. If it's okay, what we're going to do now is thank our